So here we go. This was what we talked about on last Wednesday, right? We started 7.2. We talked about the fact that we have an inverse and an original function, but they're not the same function. So we can't just cancel them out and take what's inside. It doesn't work anymore. But PEMDAS applies, right? So we said that you're going to do the parentheses or the brackets first using your information, you know. Then apply that to the outside function. So we talked about that. We said that in this case here, because it's inverse cosine, cosine's a crown, right? It's only valid in quadrant 1 and quadrant 2. And then because it's positive here, the root of 2 over 2 is positive, it had to be quadrant 1. Remember that? So what in quadrant 1 gives you a cosine of root of 2 over 2? Right here, pi over 4. So this whole thing becomes pi over 4. So then you find the sine of pi over 4. Okay, you go back to your unit circle. What's the sine of pi over 4? Root of 2 over 2. And that's how you work that. It's going to be the same for example 3. Now, example 2 we said was a little different. For example 2, negative 1/3 is not a value on the unit circle. So we don't care about the angle anymore. We're going to go Pythagorean. Anytime you get a value that's not on the unit circle, you want to go x squared plus y squared equals r squared, right? That's where you're headed. And then this is negative. So inverse sine is on the side, quadrants 1 and 4. Since it's negative, we do quadrant 4. Sine is also y over r. So it's a negative 1 and a positive r. Plug those in to solve for x. Here we go. It's a positive x because quadrant 4 is a positive x. And then we just recreate cosine. Cosine is x over r. So we're going to have 2 root of 2 over 3. And that's our answer. Okay. And there we go. So does that kind of ring a bell a little bit from what we did? We're going to go over those again. But let's flip on over then. Start on example 4. Here we go. Okay, so we want to find the exact value, so no calculator, of inverse cosine sine 7 pi over 2. Okay, so we're going to ignore what's outside first, and we're just going to look at what's right here. Okay, so we want the value of sine of 7 pi over 2. Okay, that is on the unit circle. I know it sounds a little crazy, but you have a pi in the top, you have a 2 in the bottom. It's not in one rotation, which is why you don't see it, but anything with pi in the top and 2 in the bottom is a quadrantal, right? You got pi over 2 in the top, you got 3 pi over 2 in the bottom. So we are in one of those places after we have rotated around. So let's subtract the rotation out. So I know 2 pi is going to be the same as 4 pi over 2, right? So if I take 7 pi over 2 minus 4 pi over 2, just subtracting out a rotation, I get 3 pi over 2. Okay, so I can really rewrite this as inverse cosine of sine 3 pi over 2. Okay, now when you have the same original function mixed with its own inverse, you have a lot of restrictions taking place. When you have an inverse that is not the function's inverse, you don't have any restrictions on the original function. So I don't have to worry about where this is. I can just find what is the sine of 3 pi over 2. I mean, it is in its situation anyway, but so cosine would be 0. Sine would be negative 1. Okay, so this would be negative 1, which means now I want the inverse cosine of negative 1, right? So I want to know what angle is going to give me a cosine of negative 1. That's what I'm looking for. Okay, so I go back to the unit circle. Now, inverse cosine is only valid here. Okay, so where do I see a cosine of -1? Right here, pi. And so my answer is pi. Okay, does that make sense? So I pulled out a rotation so I could figure out this value. It was actually sine of 3 pi over 2. I look on my unit circle for it. Sine of 3 pi over 2 is -1. Then I find the inverse cosine of -1. Now remember, you could have written it like this, where I set that equal to y, and then I rearrange it like this, and then this tells me y is pi. So you can always do it that way too if it helps your brain a little bit. You can rewrite it. Okay? Is everybody okay with that? Okay, let's. Yeah, you want it in pi. You want it in pi. Good question, because this is a radian measure, so you want to keep a radian measure. Okay, so no degrees, really not any degrees for this whole chapter. Yeah.
So we always want to bring it down. 5/7 over 5. We always want to shrink it.
Say that one more time.
Do we always want to shrink it, like get to small?
Oh, you don't have to. If you know what this is, you can just do it to -1. I mean, all I'm trying to figure out is that this is -1. So if you know that's -1-ish, you just put it. If you can see that that's a rotation, that's fine. But if you need help seeing it, that's when you do this. So you pull out the 2 pi. Yeah. Okay. Anybody else? Yeah? Okay.
Well, I'm sorry.
You're good.
What if you did pi over 6? No, never mind. No, never mind. No question.
You good?
Yeah.
Okay.
What if you did 5 pi over 6, you get 3 pi over 2?
Wait a minute. Let me think about that. What is it? If this was 5 pi over 6?
Wait, never mind. My
Okay.
bad.
It's okay. All right. It's Monday. Bless you. Bless you. You good? Okay. All right. Let's try another one. Okay. Let's see. Hold on. My camera on my computer screen is being weird. Come on. You can do it. There we go. Okay. So now I have the secant of the inverse tangent. Now we haven't gotten to inverse secant, inverse cosecant, inverse cotangent. So we're still okay. But, oh, my stupid thing. Why is it doing that? Okay. I'm just going to have to leave my pencil here and quit talking with my hands. All right. That's good. Okay. So I need the inverse tangent of 6/7. Now remember, tangent is y over x. So you're supposed to look at the unit circle. Is there any angle on the unit circle where you can put y over x and you get 6/7? No. So we're not on the unit circle. That means I don't care about any of the angles. I am simply going to use Pythagorean, and then I'm going to work backwards. Okay. All right. So inverse tangent, remember, is on the side like sine. That means I'm either quadrant 1 or I'm quadrant 4. Okay. Since this is positive, what quadrant am I in? Quadrant 1. That's important because we just need to make sure that we know x is positive and y is positive. I know we're going to square them anyway, but then when we recreate secant, that's when we need that information. Okay. All right. So tangent is y over x. So my x is 7. My y is 6. There we go. Okay. It'd be helpful if I had my paper out. Okay. All right, so I'm going to have 49 plus 36 equals r squared. That gives me an 85 equals r squared. I take the square root of both. You can try your hardest to factor tree 85 or come up with a reduction for that square root, but there isn't anything. It's actually square root of 85, believe it or not. And we know it's positive because r is always positive. Okay. So now what we know is we know x, we know y, and we know r. That's what we've learned. Okay, now we want the secant using these guys. So if you remember, secant is the inverse of cosine. So cosine is x over r. So secant is going to be r over x. So we're going to have the square root of 85 over 7. And remember, everybody's positive because we already determined this was quadrant 1, right? Because inverse of tangent has to be quadrant 1 or quadrant 4. And since these were positive, we're in quadrant 1. And there we go. So we kind of had to work a little backwards on that. Trig is all about some detective work. Okay. Everybody okay on that one? Okay. All right, let's try the next one. All right, major detective work on this one. Okay, so again, here we go. Inverse tangents inside, we're going to do it first. Inverse tangent tells us we're either quadrant 1 or quadrant 4. Now he's negative, so what quadrant are we in? We're in quadrant 4. Okay, all right, in quadrant 4, x is negative. Oh, sorry, x is positive, y is negative, right? Okay, so let's think about this for just a second here. So what point is going to give us a tangent of negative root of 3? I want to know which point, which angle are we looking at? So we've got y over x that's going to equal negative root of 3. All right, we have to think about this. So I think we can all agree it's not going to be this one. Can we all agree on that? Because if it's y over x, that's going to give us a negative 1. It's got to be one of these that has the root of 3 in it. So do we want this one that's going to be y over x and put the root of 3 in the bottom? Or do we want this one that's going to be y over x that puts the root of 3 in the top? What do we think? That one down here. If we have a root of 3 in the bottom, what are we going to have to do to it? Rationalize it. And then you're not going to end up with a root of 3 in the bottom. You're going to end up with it in the top, but you're going to have a 3 in the denominator. So it can't be this one. It's got to be this little guy. Okay, so if this is going to be our angle, we can't put 5 pi over 3 because remember, this is lava over here. We can't go through the lava. So how am I going to represent this guy right here, this 5 pi over 3? Negative pi over 3, right? So that's what we're looking at. We're going to have cosecant of negative pi over 3. Okay, just so you can see how that works out, remember that point was 1/2 negative root of 3 over 2. If I were to put that as my little tangent, look what happens. Doesn't hurt if you're ever unsure to just go ahead and recreate it. And then you can see, oh yeah, that's exactly the correct point. That's what we're looking at. We're looking at 5 pi over 3, but I have to call it negative pi over 3. Okay. All right. So now I want the cosecant of negative pi over 3. Okay, that's what I'm looking for. Now you can rearrange it. You can make it equal to y and then, well, no, sorry. I can't rearrange it. That's not an inverse. Forget I said that. I got carried away. We don't know how to do that yet. Okay, so I want the cosecant of negative pi over 3. Okay, here's my negative pi over 3. Cosecant is the reciprocal of who? Sine. Here's my sine right here. So I'm not going to put negative root of 3 over 2. I'm going to put the reciprocal, which is negative 2 over root of 3. Perfect. Okay, a lot of things to be thinking about there. It wasn't one of those super easy ones we could just pluck right off the chart. All right, we're still not done because now we have to rationalize. And we're going to end up with negative 2 root of 3 over 3. Okay. Is that one okay? That had a lot going on. Everybody okay on that? Okay. All right. Let's scoot them up a little bit here. Okay. So last one of these, and then we're going to talk about some inverses of those reciprocals. Okay, here we go. Again, we have an inverse tangent in here. Okay, so think about your unit circle. Is there a point on your unit circle, especially in quadrants 1 and 4, that you could make a fraction of y over x to give you a -7? No, nothing. So remember, when in doubt, throw Pythagorean up there. Okay, so now we need to think about what do we have here. Okay, we have a tangent of -7. Tangent is y over x. Everybody agree with that? So this is -7 over 1. Okay, so who does the negative go with? Does it go with the 7 or does it go with the 1? Well, remember, inverse tangent's only good in quadrant 1 and quadrant 4. So if he's negative, he's down here in quadrant 4, and in quadrant 4, x is positive, y is negative. So make sure that your negative goes with your y. So my x is going to be 1. My y is going to be -7. There's my r squared. Okay, I'm going to have 1 plus 49. I'm going to have an r squared of 50. Take the square root. Remember, you can pull a 25 out of there. Square root of 25 is 5, left with a root of 2. So you have an r of 5 root of 2. So now you have x is 1, y is -7, r is 5 square root of 2. You got everything you need. And we want sine. Okay, sine is y over r. We're going to have a -7 over 5 root of 2. Okay, we still have to rationalize, but everybody good on that part? Okay, here's where, depending on your algebra teacher, you may be doing a little extra work. So let's just talk about this for a second. Some teachers, my teacher when I was in school, would have us, if there was a root in the bottom, would have us rationalize the entire denominator. So she would have us multiply top and bottom by 5 root of 2, because that's what's in the denominator and you have a root in the denominator. There's nothing wrong with that. If you multiply top and bottom by 5 root of 2, that's okay. You're going to get that root of 2 out of there, but you're going to have bigger numbers and you're going to have canceling and you're going to have a chance of making a mistake. The 5 doesn't actually have anything wrong with it. Who's the problem? Root of 2. So you really only truly have to multiply by root of 2. And then you get -7 root of 2 over, be careful here, 5 times 2, which is 10. There's your answer. Now, if you multiply top and bottom by 5 root of 2, that's great. You will reduce right down to this and you'll be just fine, but you don't have to. Okay. All right, everybody good on those? I'm good? Okay, let's talk about those reciprocals. All right, the good news is you already know how to do these because we're just going to look back at their originals. Okay, everybody okay if I flip? Okay, here we go. Got a nice little box over here. Okay, so remember, I haven't been doing a good job of telling you guys your My Math Lab stuff. Everything we've done up to this point was My Math Lab numbers 12 through 17. Just so you know, that was 12 through 17 because we did the back first of 7.2. 7.2, 12 through 17. Okay. All right. Now let's talk about these guys here. Okay. Let me scooch you over. Everybody can see. All right, here we go. So they kind of shoved them all in this little box together. So I'm just going to kind of make 3 little areas of them here. Okay, so we have inverse secant. Fantastic. We know that he is really just going to be inverse cosine, basically with one extra restriction. Because if you remember, if you look back at secant's graph from way back when, okay, here's cosine's graph, here's secant's graph, okay? So what they did for secant's graph is they took this piece and they took this piece. So they kept you between 0 and pi, Okay, they kept you with cosine in that crown because it's his reciprocal. They kept you in quadrant 1 and quadrant 2. So they took this little piece just like cosine did, but look at the issue. There's an asymptote there. So it is undefined at pi over 2. So just kind of keep that in mind. He is the inverse cosine restriction, but if you ever end up with pi over 2 as your answer, you have to write undefined for inverse secant because he's not defined at that because of where they took his graph. He's got an asymptote there, okay? All right, so we're just like cosine. We're good in quadrants 1 and 2. Okay, let's look at cosecant. Cosecant, remember, he is just like inverse sine because that's his reciprocal. Okay, so he's going to be quadrant 1 and quadrant 4, but he has one little restriction. Let's go back and look at our graph. Okay, here's our sine right here, right? Okay, so sine took this guy to this guy as his restriction. And so because they wanted to keep those similar, they did the same thing for cosecant. So you're in quadrant 1 and quadrant 4, except that right here at 0 is an asymptote. You can't see it because it's on the y-axis, but there's an asymptote there. So if you ever come up with y equals 0, you have to write undefined for cosecant, okay? And then, not last but not least, be careful here, cotangent. Now, you know somebody has to be difficult. Well, welcome to cotangent. Okay, cotangent is not the same as inverse tangent. I know that's his reciprocal, but it's not the same. It's just not. So if you look at tangent's graph, remember this little dude? Remember the little disco dude? Here's his graph. We took it from here to here, right? So he's quadrant 1 and 4, just like sine. That's what we did with him. But unfortunately, the cotangent graph and the tangent graph don't have anything in common. You know, we have to draw sine and cosine to get cosecant and secant. We don't have to draw tangent to get cotangent. They aren't the same graph. They don't have anything in common. So this is tangent, the little disco dude right through the origin. This is cotangent. He's the totally different dude, and he doesn't go through there. So they put cotangent in with cosine. They are the ones that are related. Inverse cotangent and inverse cosine are related. They have the same restrictions because they're 0 to pi. So the only time that's ever kind of tricky is when you put it in your calculator. You really don't have to think about that or know it until we get to calculator work. Okay, and we'll talk about that more when we do. But just notice, these are the same restrictions as inverse cosine. Just keep that in mind. He's the crown, cotangent, cosine. He's up there with that. He is not related to inverse tangent at all in any way. So that is going to be your My Math Lab number 2 question. I think they just ask you all these little restrictions. You know, it's a drop down box and you just fill it in. Okay. All right. So not inverse tan. So we can't work backwards with him. All right. So let's jump right in and do some problems then. Okay, find the exact value of inverse cosecant of 2. Okay, this is actually going to be my Math Lab number 1. They start out with cosecant. All right, first of all, we need to look at his domain, right? Because we haven't really checked the domains of these guys. The domain of cotangents, all real numbers, just like tangent. But the domain of these guys is going to be the absolute value of x greater than or equal to 1. Because remember, they're parabolas that go all the way up and all the way down. So if you take the absolute value of those, as long as they're bigger than 1, Because remember what's happening between -1 and 1? They're undefined, right? Because there are little reciprocal functions in there. You're good to go. So we are definitely greater than 1. So our domain is good. We don't have to worry about it. If it's not good, what do we write? Undefined. Okay, so we're good. Okay, so let's think about this. I'm going to rewrite it. Oops. Equal to y. Okay, and then if I switch it around, I get cosecant of y equals 2, right? I just switched it around. That's it. Okay, so where is this valid? Well, remember, cosecant and sine are both valid. They're inverses in quadrant 1 and quadrant 4. So that's what we're looking at. Okay, if this bothers you, change it to sine. I don't know why I can't. For all the higher level math I've had, my brain does not flip things over. So this I struggle with. So I just rewrite it as this, and then I can totally do that. And by the time I write it, I know the answer. So these are exactly the same. You just figure out which one you'd rather solve. So if the 2 is positive, we're in quadrant 1, right? So in quadrant 1, the cosecant would be 2 or the sine would be 1/2. What are we looking at? Pi over 6. My sine is 1/2 or cosecant is 2. So y equals pi over 6. And there's my answer. These poor people, I got to quit putting my unit circle on there. It messes them up. Okay, does everybody kind of see how I did that? So I checked my domain. I checked my quadrants. If this is negative, I'm in quadrant 4. I need a negative rotation. If it's positive, I'm in quadrant 1. So I'm quadrant 1. Then I write it over. If you can jump right from there to there, great. If you want to rewrite it as the reciprocal and put it back as sine, you can, and there you go. Okay. All right, let's try this guy down here. Same situation, cosecant. Okay, let's try our domain. Sure, he works because he's also equal to 1. So we're good. All right. So now I'm going to look and see. Okay, this has to be either quadrant 1 or quadrant 4. This is a positive 1. So which one am I in? 1, but I don't really have to know that because it's going to be a quadrantal. Okay. All right. So here we go. I can think about where is cosecant 1, or I can think about where is sine. What's the reciprocal of 1? It's 1, right? If you flip 1 over 1, we're still 1. So where is sine 1? Well, you're allowed to be here all the way to here. So he's right here at pi over 2. Okay. All right, so y equals pi over 2, and you're done. What if this was inverse secant of 1? Would this be an acceptable answer? Remember, inverse secant can't be pi over 2. So if that had been inverse secant, you would have had to write undefined. Okay, is that all right? All right, okay, let's keep going. Let's try a secant now. Okay, so again, we're thinking about cosine in this situation. Remember, cosine the crown. So we're trying to figure out, are we quadrant 1 or are we quadrant 2? Well, let's check our domain. If I take the absolute value of -2, I get positive 2, and I'm good. And he's bigger than 1. Okay, so let's write this over. Okay, he's going to either be 1 or 2. He's negative, so which quadrant are we in? 2, right? If you're in quadrant 1, you got to be positive. Okay, so I'm in quadrant 2. I got to think about that. So I can look for a secant that equals -2, or I can look for a cosine that equals what? -1/2, right? I just flip it. I find the reciprocal. You have to flip it if you're going to do it that way. So here we go. I'm in quadrant 2. I'm looking for a cosine of -1/2. And we get 2 pi over 3. And that's my answer. Not bad? Okay. All right. And let's try inverse secant here. And then we're going to hit some cotangents. Okay, same thing here. Again, this is where you got to be careful. You got to think a little bit deeper than what we've been doing because this one has been rationalized. So, all right, let's take it one step at a time. Let's see, if I take the absolute value of this, is it greater than or equal to 1? Well, it is. If you're not sure, put it in your calculator and hit enter. It'll give you a value. It's definitely bigger than 1, so you're good. All right, so if I want to write it over, I can. All right, for cosine and secant, the inverse is quadrant 1 or 2. Okay, he's positive, so I'm in quadrant 1. Perfect, okay. So then I can say, all right, I either want the secant value 2 root of 3 over 3, or, okay, this is where it gets a little complicated. If you have a root in the top and you have the same radicand, that's the stuff under the root, in the bottom, that means your value has been rationalized at some point. Does that make sense? This has been rationalized. This originally had a root of 3 in the bottom. And when you multiply root of 3 by root of 3, what do you get? 3. So this one has originally been rationalized. So it originally had a square root of 3 in the denominator, which means that when you are looking at your 1/2 and your root of 3 over 2, right? You're looking at one that put a root of 3 over 2 in the bottom, which for cosine means it was an x value. So you're looking at an x value in quadrant 1 that had a root of 3 in it. Does that make sense? So if I look in quadrant 1 for a root of 3 over 2 as my x value, my answer is going to be pi over 6. Now, if that was way too much for you, let's just think about this. We can also find it really simply. I flipped this. I've been flipping every one of these. So let's flip him. Okay. Whoops, I forgot to put him in the top. If I flip that, I get 3 over 2 root of 3. If I rationalize that, I get 3 root of 3. 2 times 3 is 6. This gives me root of 3 over 2. So I'm also, you could think of it as I'm looking for where does cosine equal root of 3 over 2? And it equals it at pi over 6. So if you need to, just do the reciprocal and do the math. It'll take you right back there to it. But if you really think about it, take a rationalized value. You would have root of 3 in the denominator. What has an x with the root of 3 in it? And then you're putting it down there. Okay, and you know that's your value. Okay, so I just took this and flipped it. I rationalized it. And then I knew that was my answer. Okay. Is that okay? Yeah, kind of? Okay. All right. One more page of these and we're going to look at calculator. Let's do some cotangent though, just to make sure that we know how to do this. So far with inverse secant and inverse cosecant, we have used their reciprocals to find the values, right? We have used, okay, the reciprocal of cosine, the reciprocal of sine, because it was super helpful. We can't do that with cotangent. But that's okay. You're just going to use the definition of cotangent. That's all you're going to do. So let's see, we want to remember, all right, I have to do this weird thing with this camera for whatever reason today. Okay, what is cotangent equal, by the way? Cotangent is going to be x over y. Let's keep that in mind. Okay, so we don't really have to worry about finding the reciprocal of tangent because we can't find tangent anyway. It's not like it's right in front of our face. We have to calculate it. So we'll just calculate cotangent. Just remember to put the x on the top and the y on the bottom. That's all we got to worry about. Okay, so first of all, we need to check our domain. Well, if you look at cotangent's domain, okay, hold on. Gotta get our thing here. Look at our domain. It's all real numbers, just like tangents. So that is what they have in common. So we don't ever have to worry about this being a weird situation. Okay, so we're good. Our domain is good. All right, now we want to say, okay, cotangent of this equals y. All right. So he is restricted to cosines restriction, which is the crown, right? So he's quadrant 1 and he's quadrant 2. This is a negative, so where are we? Quadrant 2. Perfect. Okay. So what I want then is to find the value of cotangent in quadrant 2 that's going to give me root of 3 over 3. Now remember, x over y. Let's think about this value for a minute. We have a radical in the top, but what do we have in the bottom? The same radicand without a radical. So this value was rationalized. Everybody see that? This value was rationalized. So we know it's not going to be the root of 2 over 2 situation because that's going to create a ratio of 1. So if we're thinking about our 1/2 and our root of 3's over 2, we want the root of 3 over 2 to be in the bottom because this has been rationalized. So that means the 1/2 is in the top. So we're looking for a 1/2 of x, and we're looking for a root of 3 over 2 as a y. Does everybody kind of see how I'm thinking about that, why that's working? You don't have to. You can just try them both. You know it's not going to be, I had lost my unit circle. You know it's not going to be this dude. So you can just try both of them. You can put x over y, and then see which one comes out to be negative root of 3 over 3. I mean, it's only 2 choices. It's not like you're having to try a bunch. But if you want a little help in deciding that, you want the one with the root of 3 as the y because it was in the bottom and it got rationalized. So root of 3 as the y would be 2 pi over 3. That's going to be your value. Okay, let me get this to focus again. Okay, so let's look at that. At 2 pi over 3, this was our value. Okay, let's plug that into x over y just to make sure we're good. Here's our x. Here's our y. Our 2's cancel. We get negative 1 over root of 3. We rationalize. We get negative root of 3 over 3. Sure enough, that's what we had. Okay? And that's one of those things that just comes with practice, right? Just doing this over and over again. You're like, oh my gosh, I can rationalize in my head. I know what that's going to be. Okay, let's try it again. We have cotangent. Okay. So if I write this over, all right, this is going to be quadrant 1 or quadrant 2, one or the other. Because it's negative, it's got to be quadrant 2. Okay, so what angle in quadrant 2 is going to give me a cotangent of negative 1? This is not a quadrantal. For cosine and sine, if they are equaling a negative 1, they're at one of the axes. But remember, cotangent is, and tangent, they're x over y's, right? Or y over x's. So you have to have the same value for the x and the y. So in quadrant 2, what do we think our answer is going to be? The 3 pi over 4. Because if we put x over y with them being the exact same value and we reduce, we're going to get a negative 1. That stumps a lot of students. They see that negative 1 and they want it to be one of the quadrantals, but it's not. With cotangent and tangent, if you ever see a 1 or you ever see a negative 1, you're looking at one of those pi over 4 reference angles. Okay, so this is going to have to be 3 pi over 4. Okay. All right, everyone okay with that? Hanging in there? Okay, 2 more. Let's just make sure we're good here. All right, let's go back to cosecant a little bit. Let's look at a couple of strange ones. These ones I would consider a little bit tricky. Okay, so first of all, I'm back to a domain that I have to check on. Okay, so is square root of 2 equal to 1 or bigger? If you're not sure, put it in your calculator and you'll find out, yeah, it's like 1 point, blah, blah, blah. So it's good. Okay, you're good to go. Okay, so now we're ready to take this, set it equal to y. Cosecant follows his reciprocal, which is sine, on the side. So we're either quadrant 1 or quadrant 4. Well, root of 2 is positive, so we must be quadrant 1. Okay, so I can rewrite this if I want. Cosecant of y equals root of 2, or sine of y equals, what's the reciprocal of root of 2? 1 over root of 2. But then you have to rationalize it. So it's also like finding which sign in quadrant 1 is equal to root of 2 over 2. So that one was a little trickier, right? So all we did was flip it. We rationalized it. Where in quadrant 1 is sine equal to root of 2 over 2? That's a pi over 4. Okay. So that's right here. There's our cosine, there's our sine. Okay, last one of these. We'll look at our calculator a little bit. All right, here we go. If you don't check your domain, you're in for some trouble. Remember the domain situation? Is he in our domain? No. So what do we write? Undefined. Let's look at what that means for just a second though, because when we get in the next section, this is going to be important. If we were to write him over, what's another way to write 0.5 as a fraction? A half. Okay, that means if we write him over as sine, what is sine equal? 2. Is sine allowed to be 2? No, look at your unit circle. He's between -1 and 1, right? So that's another indication there that if you ever had sine of y equals 2, that it would be undefined. Okay. All right, let's look at our calculators then. So if you have them, pull those out. Because now it wants you to find these, but it wants you to do it in your calculator. So by the way, all those examples that we did, the big mix of examples, those were my math labs 3 through 8, okay, that we just did with those inverse reciprocals, you know, the secant, cosecant, all that good stuff. The calculator ones are going to be 9, 10, and 11. So that's what these are, 9, 10, and 11 for your My Math Lab, okay? All right, so here we go. Let's remember something before we get going here. So remember, you need to be in radian mode. Inverses occur in radians, so check your mode. You might have moved it and been in degree mode. That'll mess you up. Make sure you're in radian mode. Okay, next thing we're gonna look at, do you remember, what if we, that's not gonna work. I'm gonna have to turn on my light. Maybe that'll work. Yeah, okay. So, of course we have sine, cosine, tangent. Do you remember? And then of course we can do inverse sine, inverse cosine, inverse tangent. Now I'm gonna get to the remember. Do you remember how we would find secant in the calculator? Like if we wanted to find the secant of a value, how would you do that? You remember? So if you wanted secant, you would do 1 divided by cosine, right? Of whatever that value is, okay? So kind of keep that in mind. All right, so let's I'm just gonna draw a little so I don't get it messed up here. Let's do this here. Okay, well, we don't have an inverse secant button. Everybody see that? We have an inverse cosine button, but we don't have an inverse secant. So we're gonna need to rewrite this in terms of inverse cosine. So we're gonna write it over as inverse cosine. But remember, secant's the reciprocal, so it's not going to be the inverse cosine of 3. What's it going to be? 1/3. Good. It's going to be the inverse cosine of 1/3. So that's what you're going to put in. Okay. We're going to do inverse cosine, so second cosine of 1/3. And we'll just round to 2 decimal places. So you get 1.23. Everybody good with that? Okay. Do not forget to make this the reciprocal. Okay. B is going to be just as simple here. So what's the reciprocal for cosecant? Don't listen to me because I'm writing weird stuff. Sine, right? So inverse sine of, what's the reciprocal of -1? -4. I know, just, thank you. It's a Monday. I'm just going to give you all the answers. We'll go home. Okay. All right. So second sine, -1/4. We get -0.25. Ta-da. All right. Well, we're just on a roll. Be careful. Look who just joined the party for C and D. Cotangent. Can I do second tangent, inverse tangent for cotangent? No, they have nothing in common. I cannot use, write that somewhere, cannot use inverse tangent. Now is when that matters, because we could kind of just forget about it when we were doing the other stuff, but this you have to know. So who do I have to use? Who did we say had the same restrictions? Inverse cosine. So in order to use inverse in your calculator, you have to use the function with the same restrictions. It worked out great because secant and cosine had the same restrictions and they were reciprocals. Yay. Cosecant and sine, same restrictions and they were reciprocals. Yay. Cotangent and tangent, well, they're reciprocals, but they don't have the same restrictions, so we can't use it. So you're going to have to change both of these to whatever that was, cosine inverse. That's what you're going to have to do. Now, there is no way for you to just automatically take 1/2, which is x over y, right, according to cotangent, and just poof it into cosine the way that we did this. So where do we go when we get stuck? Pythagorean, x squared plus y squared equals r squared. So even though they want you to do it in your calculator, and even though you really just want to grab your calculator and punch stuff in, you can't. You're going to have to do a little work first when it comes to cotangent. Okay, so we know this is x. We know this is y. Okay, they're both positive, so we must be in quadrant 1, which is great. All right, so we're going to have 1 squared plus 2 squared equals r squared. That's going to be, what is that? I'm making stuff up. That's 5 equals r squared. We take the square root of both sides. R equals 5. Okay, I need more room here. I drew a little box, but my box is too small. All right, so now we're going to use inverse cosine because it's still an inverse. It's still an inverse. But now, what letters do we need for inverse cosine? X over R. And it just turns out you have X, Y, and R. So you're going to put X over R. And you don't have to rationalize it. It's going right into your calculator. Your calculator will do it for you. So then you're going to do inverse cosine of X divided by R. And your answer is 1.11. Okay, that's your answer. So by the way, what if you weren't sure? What if you're like, oh, how far off could it really be? What if I just do second tan, or I'll do inverse tan of, let's see, cotangent's 1/2, I'll flip it and do inverse tan of 2. Oh, that one came out. Forget it. Sometimes they work, sometimes they don't. It depends on what quadrant they're in. Dang it. We'll do the next one. It won't come out. Okay. Yeah, that one comes out weird. Okay. Okay. All right, here we go. So ignore that. That was supposed to be a big lesson learned. All right. Okay, here we go. So I can't throw this in as inverse tangent, but if I put this over 1, I know I have x over y. Okay, be careful here. Cotangent, right? The inverse cotangent is quadrant 1 and quadrant 2. So if it's negative, I'm in quadrant 2. Which one of these, the x or the y, is really negative here? The x. Okay, so my x is -2, my y is 1. All right, this is going to come out to be a lovely root of 5 equals r also, same values, just different order. Okay, so now I'm going to take inverse cosine. Remember, that's x over r. So my x is negative and my r is root of 5. Okay, so I'm going to put in inverse cosine -2 divided by square root of 5, and I get 2.68. Okay, I'm not telling you. Huh? It works too?
No, I'm saying it works bad.
Oh, it works bad. Yay. Okay, I was afraid to do it in front of you. Don't judge me. Okay, so what if we try to do our inverse tan now? Inverse tan of -1 divided by 2. That's definitely not the same answer. So, yeah. So quadrant 1 will work, but the other one won't. Yeah, because they both have quadrant 1 in common, right? But then cotangent switches to quadrant 2 when it's negative, and tangent switches to quadrant 4 when it's negative. So that's the problem. It's with the negative value when you do the inverse. That messes you up. Before you put it in? Oh, you could do that. You'll still get the same answer. Yeah. Yeah, you can always rationalize.
What happens if, like, do you recommend doing it, that process with quadrant 1?
Yeah, I always just do it no matter what, but you don't have to if it's quadrant 1. You'll be fine. Yeah. Okay, let's try it one more time because he's negative. Here we go. Okay, so that's either going to be quadrant 1 or quadrant 2 cotangent. Now he's negative, so we have to be in quadrant 2. Remember, he's x over y. We already determined that x is the one who's negative in quadrant 2. So -5 squared plus 1 squared is r squared. That gives me square root of 26 equals r. That looks like something that really ought to be able to be reduced, but it can't. It's just root of 26. Okay, so then I'm going to put in inverse cosine. My x is -5. My r is root of 26. If I put that in the calculator, I get 2.94. So again, that's one that would definitely mess up because we're negative, right? Okay. All right, and then just to make sure we can go back and do this now that we've been screwing around with cotangent. Okay, secant's one of those that works really great. So what's his reciprocal function? Cosine. All right, I don't want to put in -7. What do I want to put in? -1/7. And there you go. Okay, there you go. So that we're just going to squeeze in a little 7-3. Okay, since we don't see each other Friday or Monday. But that is section 7.2. So now you can officially do section 7.1 and 7.2. That is supposed to be 2.94, but that 9 looks like a lollipop. Yeah. Okay, we're ready for 7.3 a little bit. So you get a little bit of a break from inverses, okay? And we're gonna go do some algebra. And then we're just gonna throw in the unit circle a little bit as needed. So it's really not bad, okay? All right, so let's talk for a few minutes here. Section 7.3, you're page 15 through 20 on this, okay? So again, most trig equations are going to use radians, but check your interval. What am I talking about an interval? They're going to give you an equation. It's going to be an equal sign in there. You're going to be solving it. So we're going to have things that look like sine theta equals, I don't know, at some point this. Let's say that might be where you end up. I know it looks inverse-ish, but it's not inverse-ish. It's just inverse adjacent. Okay, so, but that's where you're going to end up. So we're going to kind of get rid of x's and y's for a little while, and we're going to go to theta. Okay, you're going to be solving for angles. That's what you're going to be solving for, is to try to find the angle theta. Next to every equation, you're going to see an interval. So it might look something like this. Okay, so there's theta. It's just telling you it's in one rotation. It's telling you all your answers can be found from 0 to 2 pi, one rotation. Why does it have to tell you that? Because remember, otherwise your answers are infinite. Because if I ask you to find, you know, where does sine equal 1/2? Okay, well, sine's 1/2 here, sine's 1/2 here. And then if I make another rotation, it's here and here, and another one is here and here, not to mention all the negative ones I could make. So when you solve a trig equation, you actually have infinite answers. So that's kind of ridiculous. So they give you an interval and they say, we're just going to do this over one rotation. And that way you're kind of contained. So usually 99% of the time, your interval has a pi in it. So you know you're using radians. If for whatever reason this said 0 to 360, then your answer would need to be in degrees. But I don't remember that ever happening in here. So just throwing that out to you. Okay. All right. So you're going to be solving equations just like you do in algebra. So you're going to be adding, you're going to be subtracting, you're going to be multiplying, but you can't divide. You are not allowed to divide a trig function. So that is not a little weapon in your toolbox that we can use. There are other things that we're going to do instead. Okay. We're going to remember where these functions are defined. We're going to remember that they're between -1 and 1. Okay. Your first My Math Lab question is actually this sentence right here, which says, so the cosine theta equals 2 and sine theta equals 2, they don't have real solutions because they're outside of your -1 to 1. They're not allowed to be in there. Okay. So here's what's going to happen. If you have one little trig function, a cosine, a tangent, you're just going to solve for it. You're going to use the unit circle and your interval and write any angles which give you that value. Sometimes you're going to have more than one trig function. Sometimes you're going to have a trig function squared. Well, how do you get a square off of something? You take the square root, just like in algebra. What if you have multiple trig functions? Well, you may need to factor it. You may need to pull out a trig function like a GCF. You may even have a quadratic trig equation where you're going to have to factor it. You're going to get into all kinds of crazy stuff, but don't let it throw you. If you get confused, all you do is get rid of the trig function and put an X. You guys can solve X all day long. So you do that, you solve it, and then you put the trig function back in at the end if it bothers your brain. If it doesn't, you leave it in, okay? So just like algebra, that's what we're gonna get into in this section, okay? So we're gonna start out a little strange with general solutions. Our first two examples are gonna be a little bit weird. We're gonna look at what happens if they don't give you an interval. But then after that, for the rest of the packet, we're just solving equations, and students tend to be really, really good at it. So it shouldn't be an issue for you at all. But we'll stop there and we will finish this section on Wednesday. And if you have any questions, let me know.